Mr. Sutton here, back one more time to wrap up this chapter on inequalities in lines. You've done inequalities, you've done lines. Now we're going to do linear inequalities. Specifically, we're going to do linear inequalities in two variables. So we're going to be doing some x and y axis graphing here. Real life application, we're going to represent all the possible combinations for purchasing two items. Here we go. For your warm-up, let's take this linear inequality, which we don't really know how to graph at this point, and pretend it's a normal line and just graph it with pencil. So pretend that this right here is an equals. Go ahead, pause the video and do that. Okay, so doing this, we've got a slope of 4, y-intercept of -3. So normally we would put a solid dot down at -3, and then we would go up 4, right 1, and put another dot, and draw a line like so. And if this were an equals, this would be more or less acceptable. We'd want arrows on the end. But this is not an equals. This is an inequality. Now, with inequalities, your line could be solid if you actually had an equals there. Just like an equals inequality gives you solid dots. But if you do not have the equals, if this is just less than or greater than with no equals, then we need a dashed line because we would have open dots. So we actually need to erase this. That's why I had you do it in pencil. We're going to put an open dot at -3, up 4 over 1 open dot at this point, and a dashed line through those. Again, because there's no equals on this inequality. So that's the first thing we have to be careful of here. Now, the other thing to look out for, since this is an inequality, we always have to shade something when there's an inequality involved. So in this case, we're going to be shading one side of this line or the other, and we just have to figure out which side it is. Here's the rules for shading lines. Now, normally it was left or right, but that was when we were dealing with x greater than or x less than. Since this is y greater than or y less than, if we're saying y is less than, we're going to shade below the line. If we say y is greater than, we're going to shade above the line. So when you're talking y values, less than means below, greater than means above, up versus down, right? Here, since we've got a greater than, we're going to shade everything above the line over here. And keep in mind, this has nothing to do with left and right. This is all about below and above. Now, if you're not sure you shaded the correct side, one thing you can do is take a point in the side that you shaded, like 0, 0, and plug it into the original and see if it comes out true. If you do that, we've got 0 here, 0 in for x, so you would write 0 greater than 0 minus 3, so 0 greater than -3. Is that true? Is 0 really greater than -3? That is true. So you can test any point over here and confirm that you've got the right answer. All right, it's party time. Let's say you and your friends decide to throw a party. You go to Market Basket to get some orange soda, $1 a bottle, and some Doritos, $4 a bag. It's an orange party, apparently. Let's say you have $20. There's Andrew Jackson. We want to know all the possibilities for what you could purchase. So let's let X be bottles of soda, and Y will be bags of Doritos. Let's see if we can set up an inequality. Pause the video and see if you can set up an inequality to describe what you can purchase here. You got something? Well, either way, here's what I've got. We could take all the bottles of soda you have and multiply them by 1 to get the money you spent on soda, so that'll be 1x. The money you spent on Doritos, that's going to be $4 times Y bags of Doritos. And if you add those two totals together, that should be no greater than, less than or equal to, 20. So there's an equation we can use to describe the situation, an inequality. Now pause the video again, go ahead and see if you can graph that. In order to graph this, we need to put this in slope-intercept form. So subtract the x, and then divide by 4. So that'll be y less than or equal to -1/4 x plus 5. We didn't have to this time around, but keep in mind, if you divide or multiply by a negative, you still have to reverse the inequality. It doesn't matter that it's two-dimensional lines versus one-dimensional number lines. Dividing by a negative will always reverse the inequality. But fortunately, we didn't have to do that on this one. So picking out our slope and our y-intercept, we've got a slope of -1/4, y-intercept of 5. Since we've got the equals this time around, what kind of lines and dot are we going to have to use? You got it. Solid dots, solid line. So we have a y-intercept of 5. That'll be right here. And our slope is telling us to go down 1, right 4, another solid dot there, and a solid line to go through those solid dots. So there's the line part of it. Remember, we have to shade one side or the other. Since we've got less than, and you should always look at your slope-intercept inequality. It's the last inequality that tells you which way to shade. Y less than means we have to shade below. So that's going to be everything down here. So all the stuff below this line, these are all the combinations of sodas and Doritos that you could buy. So you could buy 3 sodas and 2 bags of Doritos, or even more sodas here. One thing, just from real life interest here, probably can't do any of these negative sort of things unless you're somehow selling them a soda or a Dorito back, but it at least gives you a picture of what you can do. We'll wrap up this lesson with a couple oddball cases. So for this one, we've got y less than -3. Now, always keep in mind, what if this was an equals? Ask yourself, if this was an equals, what would I do? Since we just have a y, that's the hoi in hoivux. So that's a horizontal line going through -3. And we've got no equals, so we need an open dot or a dashed line. I'll just put an open dot on -3 to hold my place, and then I'll draw a dashed line through it. Since this is y less than, that means we have to shade below. So that's everything down there. See if you can figure out this next one on your own. So hopefully you figured out that this is another hoivux line. This is going to be a vertical line going through the x value 2. So solid dot, solid line, because we've got the equals. So there we go. And now, which way to shade? If you've been thinking about this in terms of, always shade above or below, first off, we always had y as the variable when we were doing that. But second, notice you can't shade above or below a perfectly vertical line. It just won't work. So for these, you're going to go back to our old way of thinking. You're just going to be shading left or right. It is x, so it should just be left or right anyway. So if there's no y, just shade in the direction of the inequality and call it a day. In this case, we're pointing right, so that means we shade right. So that's it for linear inequalities. Nice way to wrap up a chapter on lines and inequalities. Until the next chapter, this is Mr. Sutton, signing off.